So, friends, we have derived the transfer function for a single degree of freedom system in our last video. Today, we will be applying the same methodology to find transfer function for a RLC circuit, an electrical circuit. We'll try to find its transfer function. So while deriving the transfer function, the first thing that is important is to specify what is the output of the system and what is the input of the system. Let me first show you the well-known RLC circuit, which you must have done in your introduction to electrical engineering course, if at all. So there is a voltage source, right? And this provides the input to the system, input voltage, right? And since this is a RLC circuit, so there is a resistor characterized by the value of R. Then there is an inductor characterized by the value of L, inductance. They are all in series. And then there is the capacitor, right? Characterized by C or 1 by C. So we are familiar with this circuit. And the current flowing through this circuit is, let's say, small I. So as I said, that it is very important that we first identify what is the output of the system and what is the input of the system. So input I have already told you, the input to the system is Vi. And let me say that the output of the system is the voltage drop across the capacitor. Right? The voltage drop across the capacitor. So first let me write the differential equation which is governing the system. Now this will become our modus operandi, right? This will become the way we'll derive the transfer function. There are other ways of finding the transfer function as well, but we will be basically using this method, that first we'll find the differential equation governing the dynamics of the system. Then we'll take Laplace transform of that ODE, and then we'll find the transfer function, right? We'll mostly be following this approach. So the differential equation governing the dynamics of this system is, we know that the Kirchhoff's law, so the supplied input voltage is equal to the voltage drop across the resistor, which is nothing but Ri, right? Voltage drop across the resistor, across the inductor is L di by dt. I'm pretty sure you know about all these things. And the voltage drop across the capacitor is 1 by C integration 0 to t I. Isn't it? This is the governing equation which governs the system dynamics, right? So as I said, that the modus operandi is to take the transfer function. Take the Laplace transform on both the sides. So that's what we shall do. So I would be taking Laplace transform on both the sides. So what would I get? Vs is equal to Vis, input voltage, is equal to what? R times Is. So the function of t has now become function of s, because I am taking Laplace transform of this equation, plus, assuming initial conditions to be 0, it will be S times LIS, isn't it? Because there is differentiation plus the voltage drop across the capacitor, integration, so it will be divided by S. So this is 1 by SC times IS. Isn't it? This is the governing equation in S domain, complex domain. So using this relation, I can find the relation for IS divided by Vs, right? The current flowing through the circuit divided by the input voltage. This can be also one of the transfer functions. If your output of the system is the current flowing through the circuit, then this can also be your transfer function. But for now, this is not our transfer function. Our transfer function has to be the voltage drop across the capacitor upon the input voltage, right? That is what is our objective we have set up. But let me first find this and eventually we'll find it. So IS upon Vs will be equal to what? Let us see, 1 by, so we'll take IS common here, right? So it will be 1 by SL plus R plus 1 by SC. Isn't it? I hope it is correct. Yes, it should. Now, as I said, that my aim is to find the ratio of or the transfer function where output is the voltage drop across the capacitor. Now, what is the voltage drop across the capacitor? This part. This is the voltage drop across the capacitor, isn't it? This is the voltage drop. So, in complex domain, if I represent it by VCS, this will be equal to what? 1 by SC IS. This is the voltage drop across the capacitor. Now I want to, what do I need to find? The transfer function where output is VCS and input is VAS. So VCS divided by VIS, right? How can I find? So let me write IS here from here. So that will be equal to what? Or let's just first write this expression, we will automatically get VI in the denominator. So here I can say this is equal to 1 by SC times IS. IS from here is V input S, isn't it? V input S divided by SL plus R plus 1 by SC. Okay. Therefore, I want this is VCS, voltage drop across the capacitor. So voltage drop across the capacitor upon the input voltage S is equal to what? 1 by S square LC plus S times RC plus 1. This is the required transfer function for the electrical system, right? Where the output of this transfer function is the voltage drop across the capacitor and the input is the input voltage to the circuit, right? In terms of block diagram, again I can show it like this. In terms of block diagram, this is the system block, plant block or process block. whatever you like to call it. I will show it like if I divide it by LC, numerator and denominator, this will be equal to LC divided by S square plus, this is divided by LC, so S R by L plus input to this will be the input voltage and output will be the voltage drop across the capacitor. I could be, to avoid confusion, I can directly write whatever I